Good evening students, welcome to basic electrical lectures. So we are doing lectures on module 4. So it is class number 10. So dear students, in this lecture we are going to study the derivation of torque equation of DC motor. So this is very much important for exam because all the topics comes under DC motor already asked in exam. So all the topics, whatever the question asked in DC motor, it is repeated question for coming exams. So this question will be asked for 5 to 6 marks. I will take 5 marks. See, before starting derivation of torque equation, so I am going to explain some basics, and whatever the basics I explained, you don't write that basics in the derivation. Okay, got it? Once basics is completed, I will erase everything. Then I will start the derivation. From then onwards, you can start writing. First, listen the basics. What is required for this torque equation of DC motor? See, what I written here is equivalent circuit of DC motor. Apply KVL to this loop. By applying KVL to this loop, minus to plus is rise, V, plus to minus drop, minus IARA, plus to minus drop, minus EB is equal to 0. So from this we can write V is equal to EB plus IARA. So this equation is called voltage equation of DC motor. So the equation what I written here, this equation number is voltage equation of DC motor. Now for this equation, you write on both the sides by armature current. Multiply both the sides by armature current for equation 1. So if I multiply by IA on both sides, then what we get? V into IA. So left hand side I multiplied by IA. Then EB into IA plus again multiply by IA. IA into IA, IA square RA. So means on right hand side it will be like this. Right hand term is this one, multiply by IA. So if I multiply by IA, EB, IA will get one term. Another one is IA square RA. So like that you will get. See now what this equation? This equation is called power equation of a DC motor. So equation 2 is power equation of DC motor. Okay. So where V into IA is called net electrical input to the armature, and EBIA is called gross mechanical power developed. So gross mechanical power developed in the armature. So gross mechanical power developed in the armature. See this one EBIA, the product of EBIA, I am considering as mechanical power developed P suffix M, PM. Okay. Next, what about this IA square RA? So this IA square RA is nothing but armature copper loss in a machine. Okay, armature copper loss. So by adding these two powers, we will get net electrical input. What is required for torque equation is this parameter is required for me. So that's why I explained this basics. So what is PM? EB into IA. Got it? Gross mechanical power developed by the armature is EBIA. So that is represented by P suffix M. Okay. So now I am going to start the torque equation. Now onwards you can write what I going to derive the equations. So I will erase all this. So let it be this equation: gross mechanical power developed by the developed in the armature. So gross mechanical power developed, that is EV into Ia. See, what do you mean by torque? See, torque is nothing but the turning or twisting moment of force about an axis, something which refuses to rotate. Okay, that is called torque. See, the motor is armature is running. Okay, so if you coupled some mechanical input to the armature shaft, externally you can applying some friction on the shaft, you can make refuse to rotate further by holding the shaft, okay, by holding the brake drum of the machine. So you can make it refuse to rotate. So their torque going to be occurs. So the torque is nothing but the turning or twisting moment of force about an axis is called torque. So now consider a wheel. Consider a wheel or brake drum. Okay, wheel or brake drum having a radius r. So this is radius of the brake drum or wheel. See, this brake drum is coupled to the motor shaft. See, this is the, let's consider this is the motor shaft. So brake drum, I am going to fix it to the motor shaft. So now, so this we can write it as a wheel or brake drum. Wheel or brake drum. Okay, so it is fixed to the shaft. Now I am applying some external, okay, friction. So using this belt, okay, so a belt is roped, a belt is placed around the brake drum. So the belt is covered on bottom of this brake drum. Okay, if you started tightening here, okay, by swivels, if you start tightening here, then what happens? This belt will get tight contact with the brake drum. So therefore, this brake drum will refuse to rotate. It won't rotate. So maximum what we can do, it should not rotate. Like that much we can apply external friction around the brake drum. See now, this whenever if you apply external friction, then that friction is acting, due to that friction, the force is acting vectorially downwards. The force is acting vectorially downwards. So repeat once again, the brake drum is fixed on the shaft, okay, and by external this belt driven. So we are going to tighten this belt so that the belt will get tight contact with the brake drum, then brake drum refuses to rotate. There torque exerts, okay. We are applying external force here. So that force is acting vectorially downwards. So this arrow mark indicates direction of rotation. Direction of rotation. Okay. So if it is not visible, I am telling the words, you can write it. So this arrow mark indicates direction of rotation. So let me say this is figure 1. So here you should write some sentence. Okay. Consider a wheel of radius r meters in which force is acting vectorially downwards on a circumferential distance as shown in figure 1. So whenever force is acting, work done will take place. So therefore we can write work done. So why red is not working? Red is not writing. Okay. Now work done. You should write a complete word. Work done in one revolution. So we are considering a wheel is rotated one rotation or one revolution. Once the wheel rotates one revolution, okay, work done will take place. Work done in one revolution is equal to, what is the basics? Work done is equal to what? Force into distance. force into distance traveled in one revolution. So I will write it again here. So work done in one revolution is equal to force into distance traveled in one revolution. So now work done in one revolution denoted by W, force is F. Now distance traveled in one revolution. What type of distance we have here? We have what? Circumferential distance. So circumferential distance is written as 2 pi r. So take this equation number 1. Okay. Now power developed. What is the definition of power? Rate of doing work is called power. Now power developed in one revolution is equal to work done by time taken. Okay. So now work done in one revolution divided by time taken to complete one revolution. Time taken to complete one revolution. See, power developed. Okay. So that I am going to write P. Power developed I am writing as capital P. See, where this power going to be developed? In the armature. What is that power developed? Gross mechanical power. Okay. So gross mechanical power, that is PM. Work done in one revolution is what? F into 2 pi r divided by what is the time taken to complete one rotation? The time taken to complete one rotation will be 60 by n. So the time taken to complete one rotation is given by 60 by n. Okay. In EMF equation of our DC generator, I given a reason why I am taking 60 by n, not n by 60. So just go through that derived EMF equation of DC generator lecture. Okay. So now simplify this. If I simplify this, you will get F into R into 2 pi n by 60. N will go to numerator. Okay. So now gross mechanical power developed. See, the product of F into R, is called force. Torque. The product of F into R is called torque, and this 2 pi n by 60 is nothing but angular speed, omega. So where omega is equal to what? 2 pi n by 60. Okay, now this gross mechanical power developed where? In the armature. So therefore I am modifying this equation. So Pm is equal to armature torque into omega value. I will write again that only. Okay. So 2 pi n by 60. So what is gross mechanical? What is the gross mechanical power developed? Given by EB into IA. So gross mechanical power developed is given as EB into IA is equal to TA into 2 pi n by 60. Rest everything is simplification. That's it. What is back EMF? What we should write for EB? EB is produced how? Due to generating action in a motor. So therefore we can write EB is equal to pi p nz by 60A. Now substitute EB value here. By substituting EB value here, then simplify, you will get final equation of torque. Let we can see how the simplification goes. So guys, I am going to erase this one. So now you write EB value here. What is EB? Pi p nz by 60A into EB is substituted. What is next? IA is there. IA is equal to TA into 2 pi n by 60. Now what is our topic? Derived torque equation of DC motor. So from this you write expression for TA. So TA can be written as, okay, so pi p nz by 60a into high A divided by this one 2 pi n by 60. So further what happens? TA equals pi p nz by 60a into high A multiplied by, now this will go to numerator, 60 will go to numerator, 60 divided by 2 pi n. Now this 60 will and this 60 will get cancelled, n will get cancelled. What is left, that you write it. So after completing here, start writing from here. Okay, once it completes here, remaining part I am going to write here. Okay, after completing here, write here. So TA equals, see, 1 by 2 pi is left, that I am writing first, 1 by 2 pi. Next, what is available next? Flux and armature current. Flux and armature current I am grouping one term. So flux into IA, one term. Next, what is left? P, Z and A is left, that I am writing here. So P, Z by A, everything is multiplication. Okay, so this is the torque equation. So unit of torque is Newton meter. Okay, now what is 1 by 2 pi? Do it in calculator. 1 whole divided by 2 pi, that gives a numerical value 0.159. Okay, 0.159. Rest everything you write as it is. Pi IA into PZ by A, where A indicates number of parallel path and P indicates number of poles. Z indicates total number of conductors, total number of armature conductors are connected in series. So this also in Newton meter. So by this the derivation ends. Very simple derivation. So simply work done one derivation is force into distance. So write that value, power work done by time, you will get like this. Then you compare with back EMF, power, gross mechanical power developed is equal to EB into IA. Later substitute EB value. Then from that you write equation for TA. Simplify. Final step will be like this. Okay. See, they will ask problems on torque equation. For that you can directly remember this equation. So this is the torque equation. Okay, got it? So you can remember like this. The cost of PZ by A is called pizza. The cost of pizza is 0.159 paisa. Pi IA is paisa. So like that you can remember on your own method. So TA is equal to 0.159 pi IA PZ by A. So this completes and you will get easily 5 marks. Okay. So before starting the derivation, I said some sentence. That sentence you should write. What is that sentence? Consider the wheel of radius in R meters in which the force is acting vectorially downwards. Okay, as shown in figure 1. Okay. Then work done in one. Consider wheel rotates 1 revolution. Therefore, work done in 1 revolution is equal to force into distance traveled in 1 revolution. Like that, you can complete the entire derivation. But don't write basics. Okay. Without basics, then you start writing. So watch the lectures with lot of patience. Okay. Don't forward it. Okay. Don't forward it and pause the video and writing everything. So you should watch only one time. You watch it. Don't watch n number of times. One time watch it, correctly watch it. Okay. So that it saves your time. And you cannot watch all the lectures in one day. So it is a daily basis. Watch one time correctly. That is sufficient. So next time if you want to watch the lecture once, so you can note down the timings from here onwards. I can watch it. So like that you can make some arrangements. Okay, while watching videos. But whatever you watched, watched without forwarding. Okay, that gives better understanding of the subject, and you can teach to your friends also. Okay guys, please like the video of this lecture and share to your friends, all P-Cycle friends of your college and other college friends. So share only to VTU students, VTU affiliated, because I am doing lectures suitable for VTU syllabus of this particular subject code 18ELE13/23. Those who watch the lectures seriously, they can score full marks in the respective modules. Okay guys, have a nice day, take care, bye bye. Meet you on next lecture, types of DC motors, its voltage and current relations. Okay.